Hey, Algebra students. In this lesson, we are going to be talking about inequalities. Now, we're used to working with equations where we have something on one side of an equal sign and another thing on the other side of the equal sign, and both things have to be equivalent to each other so that we can do all of these different things that don't change the equivalence of the two numbers, adding something to both sides, subtracting something from both sides. And in the end, we can figure out what the equality is. We can simplify so that we know what a variable equals, for instance, or the whole set of values that two variables can equal when we graph a line. Those are the sorts of things we've been doing so far. But now we're going to be talking about inequalities. Inequalities are different from equations because now we're going to be acknowledging that two things either are not equal to each other or are probably not equal to each other. They could be equal, but they're probably less than or equal to, greater than or equal to. Okay, so those are the things that we're going to be looking at in this lesson. And this is the simplest inequality lesson we can do. We're going to be talking about translating sentences to inequalities and translating inequalities that are in math statements into sentences. So let's get started with this lesson. What this is going to really do is test your ability to change math language back and forth from sentences to symbolic language. All right, number one, the quotient of an unknown number, sounds like a variable, and negative 2 is greater than the opposite of 9. I would propose that this is likely the answer. The quotient of an unknown number and negative 2. Notice I'm not choosing the equal sign, I'm choosing the greater than sign, is greater than the opposite of 9. Now, the very first time we did a lesson like this where you had to translate sentences into equations and equations into sentences, it was pretty easy because we were just basically dealing with sums and differences, quotients, and products. Now we've got all sorts of new language we have to deal with, like the opposite of an unknown number. So we have to have variables in these. So you need to pay extra attention. Uh, the next one, letter B, 0 is less than or equal to the difference of twice a number and 8. Okay, so let's think about that. Twice a number would be 2 times a variable. The difference between that and 8 would be 2 times the variable minus 8. How about this? 0 is less than or equal to the difference of twice a number and 8. Oh boy, letter C comes to an inequality symbol you're probably not used to using. What if something just says does not equal? If something does not equal something else, that means it can be greater than or less than, but not equal to. Okay, so we use this symbol for not equal to. This is the not equal to symbol. And let's just take a look. The sum of half a number is a variable divided by 2, and 3 is the sum. So n over 2 plus 3 does not equal 15. And then the last one, the product of 11 and a number, 11 times n, is less than 121. Super straightforward. 11 times n is less than 121. All right, on to letter E. We're going to be doing things a little differently. Now we're going to be writing these inequalities as sentences. The product of 12 and a number, any variable is just going to be a number, is greater than or equal to the opposite of 8. My suggestion for these, when you run into these kind of problems, is just write them out like they look. So you start at the left and write across. Letter F is the same sort of thing. 1.5 times a number plus 2.5 is less than 11.5. You could say the sum of 1.5 times the number and 2.5 is less than 11.5. That's a valid way of saying it too, but this is just exactly what's written, so it's easy to word it correctly. Let's take a look at G. 9 is greater than 1/3 times a number minus 8. Now, I wrote this a little different. 9 is greater than the difference of 1/3 a number and 8. You could write it that way, but if you want to just be very direct, you could just write 1/3 a number minus 8. All right, and then lastly, A divided by 7, or I'm sorry, a number divided by 7. You have to say a number for variables is less than or equal to 8. You could also say the quotient of a number and 7 is less than or equal to 8. All right, now, letter I is where the rubber meets the road, because a lot of times in these word problems, they do not use the words less than or equal to, greater than or equal to. You just have to figure it out. Let's take a look. The lowest temperature at which a piece of beef can be cooked rare is 140 degrees. Wait a second, the lowest temperature? So that means that any temperature that is either that is greater than this would be a temperature at which a piece of beef can be cooked rare. Does that make sense? What about the exact number 140? Can you cook a piece of beef rare at 140? Is it included? The answer, the way that this is written, the lowest temperature at which a piece of beef can be cooked rare is 140. So, yes, it is included. So, we would cook it at greater than or equal to 140 degrees to cook it rare. The formula used to convert degrees to Celsius is this: write an inequality for an equivalent reading in degrees Celsius for a piece of beef cooked rare. So here's my suggestion for this one. What I suggest is start off by writing out the exact equation that it gives here. 9 over 5 times C plus 32 equals F. Let's just leave it as an equation until the very end, and then we'll think through the inequality. So we're just going to solve this like we would an equation and get C on a side by itself because we want a reading for degrees Celsius. 9 fifths times C equals F minus 32. I subtract 32 from both sides. I multiply both sides by the reciprocal of 9 fifths to get 9 fifths off the left side. So I'm multiplying by 5 ninths. And then I get to my last step. Okay, is C going to be greater than, less than, greater than or equal to, less than or equal to? Well, again, the lowest temperature we can cook it at is 140 degrees Fahrenheit, or the equivalent Celsius temperature, which means we have to cook it at least that temperature, maybe more. So it's going to be greater than. The temperature is going to be greater than or equal to 5 ninths times the Fahrenheit temperature minus 32. And in this case, the Fahrenheit temperature, I could even plug in 140 minus 32. If I wanted to solve this, I could go ahead and do that. I could simplify everything on the right, and what I get is the temperature in degrees Celsius has to be greater than or equal to 60 degrees. All right, and that's how you do these inequality problems. So for next time, you should do numbers 1 through 30, paying attention to carefully reading and writing inequality statements and really thinking through any word